Yes. Yeah. Yeah. Good evening, all. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not? Yes.
Yes, sir.
Yes, sir.
Right. So yesterday we had introductory session. Just I'll take 5 minutes what we have discussed in the last class. What is a Google Cloud Platform and why data engineer and ETL developer? Who is a data engineer and what a data engineer does? And GCP data engineering roles and responsibilities. Various GCP data engineering products and services. Google Cloud Platform, GCP, it allows customers to have a platform like a platform as a service or infrastructure as a service and a serverless computing environment. Just like the same way that you use like uh, functions on same infrastructure used by Google, right? Just like YouTube, Gmail, Google Maps, right? Yes. So a GCP data engineer designs, builds, and maintains data pipelines using this Google Cloud, right? Yes. So talking about this data engineer, right? It designs, maintains total entire organization, entire organization's data infrastructure. He also creates data engineer is going to create complex pipelines. He handles the big data technologies, right? Talk about this data engineer and this ETL, data engineer and ETL. Data engineer maintains this entire organization, right? Infrastructure. Responsibilities of data engineer like handling big data technologies, also like working with cloud services, implements both batch and real-time data solution. Batch and what is the difference between batch and real-time? Batch means millions and trillions of records involved, right? Means every 1 hour or every 1 day or every 10 hours, right? A real time, immediately performing some kind of analytics on this data and handling all varieties of data, structured, unstructured, semi-structured, working with streaming, working with NoSQL kinds of data, right? Yes. And he need to have all the skills of a programming knowledge, data modeling, database design, big data platform like Hadoop and Spark. ETL developer is just for extracting, transforming and loading, moving and preparing data. Responsibilities like designing, implementing and managing ETL workflows. Right. We talk about a GCP data engineer, mainly like enhances the data quality, optimizing the data storage and data processing, that is data management, the data storage and data processing, right? Collaborating with the data scientist and analyst, right? Yes. Monitoring data infrastructure and implementing ETL processes. So generally a data engineer, like he is going to transform a raw data into useful format, or that whatever the processed data of this data engineer will be utilized or used by the other teams. So cleansing, organizing and manipulating data using pipelines are some of the key responsibilities, right, of data engineer. So he's going to perform transformations, cleaning, organizing, right? Yes. So I said data engineer, right? He will be collaborating with data scientists, marketing teams, product managers, associates, right? To identify the customer behavior and enhancing the structure of structure and optimizing, right? Yes. Okay. If we talk more on this DCP data engineer, roles and responsibilities, right? Hmm. Mainly is going to design, build, and maintain Design, build, and maintain data pipelines. Design, build, and maintain data pipelines. Data ingestions, data transformations, this kind of process using GCP services, right? For moving the data and processing the data efficiently done by this. And also managing data storage. Managing data storage. He's GCP data engineer is going to set up and optimize with cloud-based data storage solutions like using BigQuery for analytical workloads and using cloud storage, Google Cloud Storage, right, for storage of unstructured data. Right. So he's going to maintain a data storage. Yeah. He also ensures data quality, data quality and integrity. Implementing data validations, it has some kind of data validations, checking for the errors, and cleaning processing to maintain data accuracy and completeness, right? Yes. Performance optimization, right? Fine tuning of SQL queries, database performance, data pipelines for efficiency and readability, and using tools, various tools for and the techniques for scalability, right? And just before I said, right, he is collaborating, collaboration data teams, collaborating with the data teams. See, he need to collaborate with some data scientists, analysts, and the business, right? And like business stakeholders to understand their data requirements, right? And they need to provide the data as per their need or as per the requirement. Data monitoring and troubleshoot. The health of the data systems, the pipelines, identifying the bottlenecks and resolving the data related issues and increasing the performance. And also like the data security. The data has to be secure at each step of the process without any data leaks or data exposures. Some configuring some security measures, access controls, and GCP's identity and access management IAM to protect the data. And also need to have stay current with this GCP. He need to have in with the latest. He need to be in touch with the latest GCP services and applying the new features to the organization's data. Key services of GCP. Key services of GCP, right? Yes. GCP key services, right? Yes. Okay. For example, Observe this, you will get the total picture of this Google Cloud platform. So you require some kind of computations, some kind of storages, some kind of big data tools, technologies, right? And some machine learning, right? Yes. Hmm. Compute, storage, big data, machine learning. If you talk about this computer, computer, app engine, compute engine, right? Container engine, cloud run, okay. App engine, compute engine, right? Container engine, cloud run, and cloud functions. Yeah. We come to the storage. Okay. Cloud storage, cloud SQL, cloud storage, cloud SQL, cloud spanner, big table, and BigQuery. BigQuery. Big data, right? Yes. Yes. Dataproc, Databricks, Dataflow, PowerSub. Also, right? BigQuery. Vision API, speech API, translate API. So big data like Dataproc, Databricks, Dataflow pops up and give BigQuery, Vision API, Speech API, Machine Learning, and Translate API. So data, see the Google Cloud Platform, the Google Cloud Platform products can be categorized into 4 categories, right? Compute, storage, big data, machine learning. App engine, compute engine, right? App engine, compute engine, right? Compute is compute engine. For compute engine running large scale, if I talk about this compute engine, the running large scale workloads on virtual machines, right? And if we talk about this app engine for building scalable web applications and mobile backends, container engine, right? Running some kind of containers on this Google infrastructure, Cloud Run, say compute platform for deploying and scaling, right? Containerized applications very quickly and securely. And also we see cloud functions also, right? Serverless platform for building such event-based microservices triggered by events, right? And if I talk about this storages like cloud storage, cloud SQL, right? So this cloud storage, Google Cloud Storage, right? It's for binary objects data format such as images, medias, backups for this cloud SQL, good for cloud SQL, right? For kind of enterprise or for kind of e-commerce kind of things for web frameworks. And see, this is a cloud storage is like object format. Relational, if you talk about the relational, right? Yes. Just here, I'll write, I'll write here. If I say about the storage, right? If it talk, this is object. This will be an object format. And this Cloud SQL and Cloud Spanner, Cloud SQL, Cloud Spanner, it is kind of relational. Relational. Spanner, Cloud Spanner. Cloud Spanner also good for RDBMS and for kind of storing some kind of user metadata. And Cloudflare and Bigtable, non-relational, non-relational, or if you can say non-relational, you can say like NoSQL, BigQuery, data warehouse for data warehouse kind of environment, right? Yes. Hmm. Coming to this big data, right? Coming to this big data proc, it's for big data processing and analytics. For big data processing and analytics, this Databricks also for this data, big data processing, PySpark processing, data flow is kind of for streaming and for batch data processing, right? For PubBars it's a kind of messaging and for data ingestions. BigQuery also like the fast querying and for data analysis and for the storage and analysis of large data sets. And this various machine learning, vision API, speech API, translate API used for different machine learning tasks. Right. So here, if we talk about this, if we talk more on this cloud storage, so the main like cloud storage, cloud SQL. Cloud storage, if I talk on this Google Cloud Storage, GCS, for storage and for storing and managing unstructured data. For example, this for storing files, images, and videos. In the same, okay, just 1 second. Key services, these are the key services. If we talk about this cloud storage, Google Cloud Storage, right? Um, yeah, previously I discussed about these things. Yesterday I was discussing about this, and this is big data. Hmm, just a second. Hmm. Google Cloud Storage for storing and managing unstructured data. Here, data is stored in the form of, see, the examples of it like files, images, videos. What purpose? For storing that. For storing and for storing and managing unstructured, right? Unstructured data. Example, files, it can be images, videos, etc. Here, if you talk data stored as objects here, data stored as objects here within containers. How we call them as buckets. Understand here, data stored as objects within containers, we call them as buckets. What do you mean by objects here? What do you mean by objects? Piece of code or it's piece of data, you can say, otherwise immutable piece of data, immutable piece of data, right? Such as a file of any format. Buckets, see, data stored as objects within containers called buckets. Here, immutable piece of data such as file of any format. Buckets, nothing but containers. Containers containers used to store your objects. And projects, we have got some terminologies, right? Again, later I will brief you about all this. All buckets, all buckets and objects, all buckets and objects are associated with a Google Cloud project. And even if we talk about, there are some storage classes here. Storage classes. Storage classes. You can choose a storage class. Choosing a storage class. Choosing a storage class based on how often, right? You need to access your data. GCP offers 4 storage classes. GCP offers 4 storage classes. Standard, nearline, GCP offers, oh, sorry, standard, nearline, whole line, okay. In a simple way, standard for frequently accessed data, you go for this. For frequently accessed data, nearline, it is a low cost storage. It is a low cost storage for data accessed infrequently. Infrequently means example once a month. Example once a month. Cold line. Just I'm copying the same thing. Very low cost storage. I can say it is a very low cost storage for data accessed rarely. For data accessed rarely. Once a quarter. Here, archive. Low cost storage for data. Rarely accessed once a year. These are suitable for long term, right? Yes. So GCP offers four storage classes. So just objects, buckets, projects, storage classes. Again, types of Google Cloud storages. Google Persistent Disk is there. Google Cloud File Store is there. Google Cloud Storage. Google Cloud Storage for Firebase. Google Cloud Storage Transfer Service. Many are there. Later I discuss. I doesn't want to enter into technicals as of now. Yes. Okay. Now, if I talk about this BigQuery, one more important component like BigQuery, right? Serverless enterprise data warehouse on Google Cloud Platform. BigQuery, if you talk like BigQuery, serverless enterprise data warehouse on Google Cloud Platform. It enables BigQuery, right? It enables fast SQL queries. It enables fast SQL queries, even like petabytes of data, PB, petabytes of data, right? Yes. So here, if I talk about this BigQuery, eliminating the need of users to managing servers for the infrastructure and handling BigQuery, handling massive data sets, gigabytes to petabytes, right? Yes. And also like using BigQuery, SQL-based analytics, and also it has got some built-in ML machine learning. It integrates machine learning capabilities, enabling users to build and operational machine learning models. And also in this BigQuery, right, we have to say BigQuery Omni. BigQuery Omni, right? The feature allows for big data analysis across multiple cloud platforms without requiring any kind of data migration. And also BigQuery, even you can perform real-time analytics, that is streaming ingestions capabilities, And using BigQuery, we perform data organization. Data is organized into tables in data sets, providing some kind of structured approach, right? And also in BigQuery, we see like AI powered features and AI powered assistance for various tasks, right? Including a natural language querying. Yes. I talk about this big data, right? Big data. It is a big data revolution of big data on distributed computation, right? The revolution of big data on distributed computation, right? Any, so we see it has brought a revolution, big data, like especially like big data Hadoop. It brought a kind of revolution on distributed computing. So any big data technologies use a model called distributed computing. Any big data technologies use a distributed computing instead of single monolithic processing. Instead of using single monolithic processing, distributed parallel processing. What? Okay, one second. Monolithic, monolithic processing and distributed processing. If you talk distributed processing. So I said this big data has brought a kind of revolution in this distributed processing, parallel processing. Monolithic processing means, what do you mean by monolithic processing? A single system or a node used for processing data. That's the single system. Here, the only one system is used for both storing data. The single system is used for processing, like a personal computer, right? Here if the RAM storage is full, or if the data storage is full or RAM storage is full, we need to extend it again and again. We need to keep on extending. This is monolithic processing. But in the case of distributed processing, right? So we'll have a lot like systems which are interconnected. So big data has introduced distributed computation, right? Here, instead of single computer, we'll make use of multiple computers, distributed storage, distributed RAM storage, distributed disk storage, right? For multiple computers to run parallelly. That what we say parallel processing, distributed computation. Multiple systems will be running parallelly. Multiple systems storing the data of a single file. The data will be distributed across multiple systems, and multiple systems running parallelly processing a single data file, which is distributed, right? Okay. And we see in distributed computation, we see some kind of master slave architecture, single master and multiple slaves, right? Where a group of systems interconnected, which forms a cluster. Here mainly, okay, first before distributed computation, monolithic processing, after the distributed processing, Hadoop, and later if you see Spark has, you've got Spark, Apache Spark, Spark, or if you say now we never say like PySpark. PySpark is a Python API to use Spark, right? So here if you talk about this big data, PySpark is one of the important tool. PySpark is the Python API to use Spark. And Spark is a very high speed execution model for processing huge data, right? Yes. So here Spark implemented in multiple languages. Spark with Python, we say PySpark. PySpark is the lightning fast technology that is being designed for fast computations. PySpark is one of the demanding tool among these data engineers to work with the bigger data sets. Using PySpark, any kind of running distributed SQLs, data pipelines, and ingesting data into databases, running ML algorithms, working with the graph algorithms, data streams, right? It has got many modules for kind of SQL kind of querying, for streaming. See, Spark graphics, Spark MLlib library, Spark SQL we have got, right? Yes. Working with ML algorithms, graph algorithms, it has got many packages, it has got many features. The main feature, like one is in-memory computation is one feature. In-memory computation, everything storing and processing everything in the memory level. And secondly, second. So here MPP. MPP means massive parallel process, we say. Spark in-memory computation and massive parallel process. Spark has got massive parallel process, distributed computation, in-memory computation, many features we see in Spark. Today, at a very high rate of speed, data is going to be processed. Terabytes or petabytes of data, it is going to execute, right? Parallel processing, distributed computation, in-memory computation. Yes. So here, if you talk for Spark to execute, it requires a cluster. Now, if I talk coming to this Databricks, right? Another Dataproc and Databricks. Databricks, right? If you talk a cluster, see Spark to execute, it requires a cluster. Cluster means group of systems. Group of systems are systems we call it as nodes. Assume you got a 100 node cluster. Assume a cluster of 100 nodes. Assume a cluster of 100 nodes. This 100 nodes cluster, assume it is worthy processing 1 TB of data at a time. 1 TB of data at a time. For example, 100 nodes cluster means 100 systems, right, which are used to parallel for running parallelly, executing a single job. For tomorrow, for example, tomorrow your data volume increased. Tomorrow your data volume increased by huge amount. If the same cluster is used, speed goes down. Speed goes down, right? If more data, the same number of systems. So what you do, the solution for it, the solution, you need to scaling up the cluster, scaling up the cluster. What you do, I'll add some more systems, adding 100 systems, 100 new nodes, 100 new systems, right? We call them as nodes. 100 new nodes you will add. Again, after 1 month, again data increased. Data keeps on increasing at a very high rate. After 1 month, again 100 nodes. Again 100 nodes got added. Keep on adding the nodes because data is increasing, and to maintain the same speed, I can keep on increasing the systems. Parallel processing happens. Distributed computation is going to. So, but what is that? Every time scaling up your physical data center, scaling up your physical data center is a complex task. It's a complex task, right? Yes. So the solution, I want the same cluster in the cloud, and that too with auto scaling feature. I want with auto scaling feature. Who is providing this? Databricks. It provides a Spark cloud cluster with auto scaling feature. It provides a Spark cloud cluster, right? Databricks. Spark Cloud Cluster. It provides Spark Cloud Cluster with auto scaling feature. Again, for example, if you take one more example, auto scaling, if you talk about auto scaling, today your organization, we talk about the data load. If you talk about the data load, it requires only 100 nodes. Depending upon the data load, requires 100 nodes, 100 systems. And tomorrow data volume increased. Tomorrow data volume increased. Data volume increased means it has to extend to 200 automatically it has to extend to 200. After otherwise of processing is done, again it has to revert 100 nodes. Okay, so this is what auto scaling feature provides. Spark cluster with auto scaling feature. If data volume increased, it has to extend to 200 automatically. After processing is done, again it has to revert back to 100. Whenever there is an increase in data volume, increasing the nodes also systems automatically. It has to revert back to 100 nodes. And if you know, Spark is 100 times faster. I'm talking about Spark 100 times faster than normal disk processing. It is 100 times faster than normal disk processing. Even there are many, even if you see Hadoop has got very high speed, but even after compared with Hadoop also, right? If you see a small example, Yahoo has taken a table of 100 TB consisting of 1024 columns. There was a test done right on the speed. It has taken a table of 100 TB consisting of 1024 columns. Task was sorting based on 16 columns, sorting based on 16 columns, time taken by the various. So you see this Oracle has taken around 3.5 days to process. MySQL has taken around 6 days. Teradata, a specialized database used for data warehouse, it has just taken 4.5 hours. Netija, another specialized database used for data warehouse, it has just taken 3 hours. And finally, this big data Hadoop has just taken minutes of time, 3.4 minutes. Yes. So Hadoop has got very less speed as compared with that which have taken days of time, hours of time. But compared to this Hadoop has got MapReduce execution as compared with the Hadoop. Spark is 100 times faster than Hadoop. Hadoop MR MapReduce, right? Spark already Hadoop has taken minutes of time. Spark speed, if we see compared with Hadoop, it is 100 times faster. That's why I was saying here Spark is a very high speed processing execution. It is a very high speed processing execution model for processing huge data at a quick time, right? So it has got massive parallel processing, distributed processing, in-memory computation, loading and processing, everything happens within the memory level, right? Okay. So just I was briefing you about this big data. We have got data proc, data bricks, data flow, pub sub, right, and BigQuery. Was talking data proc and data bricks were used for this big data processing, and data flow for kind of streaming, and pub sub some kind of messaging, and BigQuery for data warehousing, right, for data warehouse kind of things. Okay. So we will be discussing about all these things: the Google Cloud Platform, computation, storage, big data, machine learning. So these are the main, what are the various key services: cloud storage, BigQuery, data from Databricks, data flow, cloud composer, pub or sub, right? Yes. Just you can just go through this course content, what I am going to discuss. So like Google Cloud Storage, Google SQL, setting up database, BigQuery for building data warehouse, data proc for big data processing, Databricks, and data flow for Apache Beam development, Cloud Composer for orchestration and workflows, data fusion for data integration, dbt, Airflow, and Terraform, right? So this is the course content. Once you can go through big GCP data fundamentals, getting started, getting GCP account with non Gmail ID, with Gmail, without Gmail, right? And GCP project and building, GCP SDK, and storage and databases, cloud storage, BigQuery, Cloud SQL, Cloud Spanner, file store, big tables. Google Cloud Storage, in brief, in depth, we'll be discussing about this Google Cloud Storage, setting up a data lake using this GCS, and just to go through this. And Cloud SQL, setting up database using Cloud SQL. And data ingestions, integrations, data processing, transformations, and data warehousing. Later you can see one by one component I am briefing. BigQuery for building data warehouse. What are the things we do in that? Data proc for big data processing, and for ELT data pipelines using data proc. And Databricks, PySpark processing in GCP, and ELT pipelines using Databricks. And integration of this Spark on data proc and BigQuery, and data flow, Cloud Pub or Sub, Google Cloud Composer for data pipeline orchestrations and workflows, data fusion, introduction to this, and building data integration pipelines, cloud functions, cloud run, Terraform, data pipelines with using dbt, Airflow, and BigQuery. Machine learning in GCP, security monitoring and governance, and real-time scenarios, right? Yes. And building streaming pipelines, batch pipelines, designing hybrid data lake using BigQuery, Dataplex, and GCS.
Database, sir, we have to.
Databricks I showed, right? We can see Databricks here.
Database, only like database, Spark.
Databricks, PySpark processing in GCP.
This is the Spark only. Spark database.
Yes, Spark only. Spark with Python implementation. We say PySpark.
No.
See, becoming a GCP data engineer and GCP job market, right? Yes, I already said everything is moving into the cloud, and previously it was on-premises. Now we are shifting to cloud and becoming a cloud data engineer, right? It has got a great boom today, and it's shifting to that cloud. It's the correct time. And that too, I said from the last, you see, couple of months, or if you see from last 1 year or 2 years, right? Data engineering, data science, and AI technologies are booming in the market. Cloud computing, data engineering skills are increasing in demand. More companies for digitalizing their solutions. And also, if you see data engineering, artificial cloud computation, and they require a lot of professionals, data engineers. They are currently highly requested or high demand for the skills in maintaining. Okay. Even top companies, they are need of data engineers, and that too with cloud business.
So, any
Even
ideas that like how many years of experience we can have?
see, this is in brief, in depth, we'll be discussing about all this. You'll be getting in-depth knowledge about all these things, right? Everything we'll be discussing point to point. I'll be showing you the practical part. Everything practical oriented, nothing theoretical here. Even people who want to shift their queries, even if you want to have a hike, and this data engineering is one of the best choice for them. And even if we talk about the pay scales, they have got highest salaries, highest average salaries as compared with other technologies. Data engineers and data scientists, the two highest paying jobs. Yes, even a lot of companies, if you talk the top MNCs, Facebook, Intel, Microsoft, Amazon, interested in hiring data engineers with a great salary packages. You can check the salary packages, right? You can see. And also many other companies like Google, Apple, Cognizant, Walmart, all these offering high paying jobs to data engineers. That too, they will be expecting a lot of technical skills from you. So you need to showcase your skills on that. So you will be getting in brief knowledge about these components, what I discussed. So just I have given overview about this GCP cloud platform. What are the things like storage wise, big data wise, and these things. Okay, you can see that course content in brief it is. Yes. From next week onwards, we'll be starting with the actual things. We'll be starting with the entering in the technical things, right? So just yesterday and today it was introductory session. So just everyone get enrolled for getting these notes, videos. So offerings from my side, I said you'll be getting each and every session video, live session video, as it is a weekend batch. If any session, if you are missing, you miss any session, you can get go through the recording and attend the next session for better understanding. All sessions are interactive sessions. Total session you will be kept in unmuted status. At any point, you can ask query, and parallelly you can do the task along with me. And so I'll be extending the session sometimes during the practicals. Soft copy of the class notes, clear notes will be provided, assignments and tasks to work with. WhatsApp, where you can have direct interaction with me. If any errors or anything, you can take snap and post in the WhatsApp. Interview questions, mostly asked interview questions and resumes, and interactive hands-on sessions, I'm saying. And also for certifications, what are the things and how your performance is measured, what are the queries, everything I'll be briefing. And apart from that, I said from DurgaSoft, this is the thing they are providing. They are providing Unix Linux shell scripting around 120 videos of Mr. Durga, and MySQL videos, right? Yes, of 35 videos. So like 5,000 worth videos will be providing freely when you get enrolled for this GCP. So next Saturday we'll be meeting and we'll be discussing more on this. So get enrolled for getting the videos, notes, and getting added to the WhatsApp. Yes, I said it is one of the booming technology right in the market. When someone was
So,
asking a query, right?
before next Saturday only, it's to enroll, sir.
Next
Like
Saturday,
tomorrow.
next class will be on next Saturday and Sunday. Next Saturday we'll be having two hours, right? 2 hours on Saturday, 2 hours on Sunday. Once we enter with the practical, still I'll be increasing it.
Okay, so can we like enroll like today or like tomorrow only, right?
What is that?
Can we enroll like today or the
Yes,
tomorrow only?
yes, yes.
Okay.
Get enrolled for getting these videos to your Google Drive notes of this. Okay.
Okay.
And getting this, you can go to that Linux, Unix videos, MySQL videos, right? By getting the access to the videos.
Okay.
And this basic Linux skills are required. Basic Linux, basic SQL, and basic Python, right? Yes, I'm getting sounds. If you got any background, you can just type your query in the chat. Any other queries you got? Yes.
So, one question in my mind.
Mm.
Okay. So the topics which you are showing in the course content is very huge. Okay. Shall we cover this in a very 10 weeks, like 10 weekend classes?
It goes to 12 weekends. And I
12.
said, and 12 weekends it goes. And I'll take some extra sessions as it's a huge syllabus is huge, I agree. But
Mhm.
we'll go with extra sessions also, depending upon the time.
Oh, thanks. And these 122 videos are pre-request for to taking up the classes are basic Linux and Linux. Like how many sessions you can come?
This Unix, Linux shell scripting and these videos, once you get enrolled after paying the fees, you will get
Mhm.
the access to that. You should get, you'll be getting the subscription to this.
Okay.
They'll help you how you can get this videos access once you
Mhm.
get enrolled. They will give you a clear email. They'll be where you can get this, how you can get this. They'll give you a email to you.
Okay, sir. Yeah.
And apart
Thank
from
you.
this, you will be getting all these videos of this current GCP, right?
Okay.
Fine.
Fine, sir. Thank you.
Is this it goes for see 3 months it goes, Avinash. 3 months means okay, 3 months it goes around
Yeah.
3 months. Just whenever after 1.5 months seeing that coverage of the syllabus, later 1.5 month I'll be taking extending the sessions, taking some extra sessions to complete it, right? Yes.
Okay.
Finally, I'll cover all those in brief. Okay, fine. Okay, fine. So if I'm done with the queries, if there are no other queries, I will sign off for now. Meet you next Saturday discussion on this GCP. So I recommend do the things practically along with me. Practicals do along with me parallelly during the sessions. If you got any errors or any queries immediately, you can share the screens. That is what hands-on we say, right? Fine. So thank you all for your time. Thank you. Meet you next Saturday. Bye.
Thank you, sir. Thank you.